solve each polynomial equation by factoring. Check the answers. So exercise A, we're told that x minus 7 by x plus 4 is equal to negative 10. We might be tempted to write, well then, x minus 7 equals negative 10, or x plus 4 is equal to negative 10. But we don't have a property called the negative 10 factor property. We have a property called the zero factor or zero product property. And so this is not a valid conclusion. We can't do that. And remember, we have to have one side equal to 0 before we can use this property. So what we'll do is we'll simplify the left-hand side first using FOIL and combining like terms. We find x squared minus 3x minus 28 equals negative 10. And then we'll add 10 to both sides, yielding x squared minus 3x minus 18 equals 0. Now we'll factor. Using our factoring technique for trinomials, the left-hand side factors as x minus 6 by x plus 3. Using the zero product property, x minus 6 is 0, or x plus 3 equals 0. Solving each of these resulting equations, adding 6 on the first equation, subtracting 3 on the second equation, yields x equals 6, or x equals negative 3. Let's check our work. If x equals 6, is 6 minus 7 by 6 plus 4 equal to negative 10? Negative 1 by 10 is negative 10. That checks out. Alright, and if x equals negative 3, is negative 3 minus 7 by negative 3 plus 4 equal to negative 10? Well, let's see, that's negative 10 times positive 1, which is equal to negative 10. So that checks out as well. So I can be confident in my solutions to the equation. All right, so again, one key to remember if you're going to use factoring to solve an equation, you have to have one side of the equation equal to 0 before factoring. Alright, and let's see, this equation, we have 24a cubed plus 10a squared minus 25a equals 0. We already have a polynomial in that standard form, and we have it equal to 0, polynomial equal to 0, so we can start factoring. First thing I'll notice is that we have a common factor of a. So I'll factor out the a. So I have a by 24a squared plus 10a minus 25 equals 0. Alright, and that's the only common factor I can take out. So now I'm going to use the AC technique on the remaining trinomial. So let's do some side work over here. 24 by negative 25 is negative 600. And then a pair of numbers that multiplies to negative 600 and adds to negative 10. So you can go through and find a whole, all the factors. Eventually, the pair of numbers we need is 20 and 30. And getting the sign right, we need a negative 20 and a positive 30. Negative 20 times positive 30 is negative 600. Negative 20 plus 30 is positive 10. Alright, so we have 24a squared minus 20a squared, minus 20a plus 30a minus 25. And let's do some grouping here. So that gives us a common factor of 4a times 6a minus 5 plus a common factor of 5 times 6a minus 5. And so what that tells us is, going back to the equation on the left, we can factor that 24a squared plus 10a minus 25 as 6a minus 5. by 4a plus 5. And now we can use the zero product property, and the only difference is now we have 3 factors instead of 2. Well, we can just set each factor to 0. So we have a is equal to 0, or 6a minus 5 is equal to 0, or 4a plus 5 is equal to 0. All right, a equals 0, that's done. 6a plus 5 equals 0. I'm sorry, 6a minus 5 equals 0. We will add 5 to both sides. So then 6a is equal to 5, and then divide through by 6, and a is equal to 5 over 6. 4a plus 5 equals 0. Let's subtract 5 from both sides. So 4a is equal to negative 5, and we'll divide through both sides of the equation by 4, and a is negative 5/4. All right, we're asked to check these, so 0 is fairly obvious. If a equals 0, then we would have 24 by 0 cubed plus 10 by 0 square minus 25 by 0 equals 0. And notice that each of those terms goes to 0. 0 cubed is 0 times 24. 0 plus 0 minus 0 is certainly 0. So that one's fairly easy to check. All right, what about 5/6? 24 by 5/6 cubed plus 10 by 5/6 squared minus 25 by 5/6. Is this equal to 0? All right, this one is not easy to simplify. Let's see, 5/6 cubed is 125 over 216. 5/6 squared is 25 over 36. And we still have minus 25 by 5/6. All right, and let's see then. 24 times 125 over 216. I'm going to use a calculator just to make this a little bit easier for me. So let's see, 24 times 125 over 216. This ends up being 125 over 9. 10 times 25 over 36. Ends up being 125 over 18. And 25 times 5 over 6 ends up being 125 over 6. Oh, that should be a minus. All right, now I'll just check that. Arithmetic on the calculator. 125 over 9 plus 125 over 18 minus 125 over 6 does in fact equal 0. So that checks out. All right, and what about negative 5/4? Similar process. 24 times negative 5/4 cubed plus 10 by negative 5/4 squared minus 25 by negative 5/4. Is this equal to 0? All right, so that's 25 by negative 125/64 plus 10 by 25/16 minus 25 by negative 5/4. Again, I'll go through this arithmetic using a calculator. 25 by negative 125 over 64 is negative 3,125 over 64. Oh, that should be a 24, not a 25. Be careful about that. So this is negative 375 over 8. 10 times 25 over 16 is 125 over 8. And a negative times a negative is a positive, and 25 times 5 over 4 is 125 over 4. And again, I'll just kind of go through this arithmetic, this additions on the calculator. Negative 375 over 8 plus 125 over 8 plus 125 over 4 is in fact 0. That checks out, so I can be confident in my 3 solutions to the equation. In example C, we have p times p plus 5 is equal to 14. So again, the first thing I'm going to do is simplify. So we have p squared plus 5p is 14. I just used the distributive property there. Now I'll subtract 14 from both sides to make one side of the equation 0. So p squared plus 5p minus 14 is 0. Factoring that trinomial by inspection with b equal to 5 and c equal to negative 14. The pair of numbers that multiplies to negative 14 and adds to 5 is a 2 and a 7. I just got to get the signs right, a negative 2 and a positive 7. So therefore the trinomial factors as p minus 2 by p plus 7, and that's still equal to 0. Now I can use the zero product property. P minus 2 is 0, or p plus 7 is 0. On the first equation, to solve for p, I add 2 to both sides. On the second equation, to solve for p, I subtract 7 from both sides, yielding p is equal to 2 and p is equal to negative 7, respectively. Let's check our work by going back to the original equation. With p equal to 2, is 2 times 2 plus 5 equal to 14? Well, that's 2 times 7, which is certainly equal to 14. That checks out. And with negative 7, is negative 7 times negative 7 plus 5 equal to 14? Well, that's negative 7 times negative 2, which is equal to 14. So that checks out as well. And I'm confident in my solutions to the equation.